is Wilson. So today I'm gonna present my mini project titled named Sustainable Tilapia Fish Pond and Hatchery Design near Mountain Area by integrating with rice field and renewable energy from solar panel and water wheel in semi-rural area. So as we all know, most of the countries in the world, a lot of poor people live in a rural area. So in order to solve this food security and malnutrition as well as poverty issues, this is the reason why I do this mini project design. So this is some of the summary we have over here, and this is my method, which is the concept I get from FAO. So it's an integration of the farm design. So this is my own drawing, and the species of fish for this design is used for is actually GIF, which is genetic improved farm tilapia. Okay. So given the plot, I assume the map is in mountain area with river. So this tally with my project titles. So the plot I chosen is 35, 38, and 40. Plot 38 will be used for grow up earthen pond for the tilapia fishes. So the pond size will be 70 meter with 70 meter length and 1 meter depth. So total of 4 ponds will add up to plot, which is plot 38, the total size for that. So 2 ponds will be reservoir and 2 will be grow out. So this will be interchanges or break cycles, so you can have the pond for sort of recover throughout the period of time. So plot 35 will be used for hatchery, which is next to the river. So you also can build a water wheel next attached to the hatchery center to provide sort of electricity. So reservoir, the function of reservoir will also be used as rainwater storage, and it will prevent flooding when heavy rain happens. So this is the water wheel I mentioned just now. So this one is more high efficiency as well as low environmental impact and fish friendly. So as we all know that good water quality is very essential for agriculture in order you have to have good production. So constant water movement in a river is important because stagnant water have lower oxygen level. So the incoming water will pass through the mesh to filter up any unwanted solid like branches, leaf, rocks, and etc. So water quality really play a big role in agriculture, and by utilizing the different height and let the gravity do the job, so the dissolved oxygen will be sufficient by water mixing through air diffusion into the water on different heights. So you will less require or dependent on the paddle wheel. So in order to further decrease the carbon emission, solar panels also installed. So this also provide alternative electricity. So hydro will also install to provide more all year long power, constant power supply. So the electricity generated will be used on powering the aeration needed in hatchery, which can be self-sustained as well. So this also reduces the dependence on incoming power supply and have less risks when you have power shortage or power outage, and reduce the cost on electricity. So normally in semi-rural area, some of it won't be have a very good connection on electricity. Some might be off-grid. So this farm design might be self-sustained for rural community and less environmental impact as well as low carbon footprint. So it's fully sustainable. So still sustainable. For a farm to be sustainable, taking care of the environment is a must because natural resources is very valuable for us. So voice model management for this farm will be utilizing so-called natural sedimentation as well as biological method to convert the waste to value. So in this case, we gotta use the biofilter, which is the paddy field. So you can grow fishes at the same time you can grow crops like paddy field to feed and also increase the food security and reduce poverty as well. So in this one will be focused on the market aspect. So in semi-rural areas, you can have access to the market and will have more consistent and reliable demand. So the producer will have more likely a wider range for them to choose on whether they want intensive or semi-intensive farming. So with this access to the market, it can be two ways in terms of selling the fish to the local nearby market, wet market. We can supply the fish protein as well as food security for the local community. On the other hand, it will increase the farmer income on the economical aspect. And the second way in terms of accessing the market means you will have access to commercial feed for feeding your tilapia. So as you know, the commercial feed will have highly nutrition as well, better production in returns. So the next one I'll be talking for handling the food waste as well as black soldier fly. So each year humans produce more than 1.3 billion tons of food and agricultural waste, and it will end up in landfill, and it will have a very serious environmental problem like in greenhouse emission, soil and underground water pollution for landfill. So by utilizing black soldier fly, which is the bioconversion or nutrition recycling of waste biomass with insect, so it will yield high product such as protein as well as chitin and thrust. So this insect derived protein, it can sort of partially replace the commercial feed or reduce the cost of the feed as well, because it's just basically using the food waste to sort of breed the black soldier fly. So it's basically converting the waste to value. Yeah, so I think that's about it on my overall idea and for my farm design. So thank you for listening, and bye bye.